Okay, good morning, everyone. Okay, today we will actually look at another paper 4 question. Okay, so I have selected one paper 4 question so we can actually discuss. So I will share my screen over here. Okay, take note. I have actually uploaded this in AIS. You can actually go and check your AIS as well. Okay, now while we are waiting for it, okay, so this one. So this is going to be, if you look over here, this is going to be a simple 10 marks question. Okay, so I just want to cover certain things. Okay, uh, let's actually go on. Okay, I'll give you 5 minutes. Okay, to actually go through this. Okay, have a look. Okay, and then I will actually check again with you guys. Okay, now just try. Okay, just try. Okay, so I'm just going to keep quiet for a while. Okay, I'll just give you some time to try, and then I will come back again. Okay. Okay, guys. Okay, let's not waste time anymore. I know that you need more time for this. Okay, but again, we should not waste time as well. Now, so I will actually start with the lesson. Okay, so I will actually guide you through how to do this question. It's a very simple question. Just testing on your, just basically, it's just testing you guys. Okay, on the concept. Very simple concept. Okay, very simple concept. Basically they are asking you that, okay, when you react with acid, what's going to happen? Okay, this is going to be hydrolysis reaction. Then what will happen when you actually react with certain oxidizing agent and so on. So you need to actually have a very good knowledge in organic chemistry to answer this. So I will actually just try to answer this question together with you as well. Okay, let's hope you guys are ready. Okay, Aditya, are you ready?
Yes.
Yeah. Okay. Now, can you tell me what is the best method to actually do this? Do you start from the top or do you start from the bottom? I gave you 5 minutes to analyze. Where do you start? Nicole, how did you do
Bottom.
this question?
Start from bottom.
Yeah. The best way is to start at the bottom, because if you look from the top, it's going to be very complicated. Okay, very complicated when you look at the boiling with acid of so many complicated molecules and so on. Okay, it's better to start from bottom. But okay, while I was doing this question, I also noticed one thing. Okay, I end up trying to figure out a lot of equations and a lot of let's say the structure of the compound. I spent a lot of time over here figuring out what is this structure, what is this structure, what is this structure, rather than actually doing one thing. Okay, after I did that thing, okay, my life became very much easier. What I did was I started to look at the question, what they want me to do. Okay, what they want me to do. So first of all, I roughly get an idea what's happening. Then after that, I try to answer a question based on the questions given. Okay, so that made my job much more easier rather than trying to actually find out or figure out what's actually happening. So if you look over here, okay, what I did was, okay, first I know that, okay, there is going to be an halogenal alkane CH2. If I draw here, Br and then Br. And when I react with KCN, okay, you notice that the 4 carbon over there. And what happens, I'm going to have 6 carbon. There is only one particular reaction that is actually in chemistry where you are going to actually react with KCN, okay, where this Br and this Br is going to be substituted to give you the CN. Additional carbon can be formed. So you have 6 carbon. So I know that, okay, this is going to happen. So I'm going to have a structure that has CN and CN, nitrile, okay, nitrile. After that, I also notice here, okay, once I have the nitrile, I do not have any oxygen in here, no oxygen. But now I see 4 oxygen. Okay, for nitrile, okay, there are 2 reactions. Okay, you just have a look at the textbook. Okay, under carboxylic acid, okay, under carboxylic acid, nitriles, okay, can actually undergo two types of reaction. One reaction is going to be with dilute HCl together with H2O and HCl. They will start to give you carboxylic acid. Another one is a reaction with sodium and ethanol, okay, where they are going to actually have a reduction reaction where this nitrile will change into NH2. They are going to actually change into amine. So I want you to go and read on this, okay? But now, looking from here, O4, I know that it is actually changing into carboxylic acid. So the CN is changing into C double bond O, OH. And then that CN over there, the other N is going to change into C double bond O, OH. So that's my thinking process over here. Then I also notice over here, I'm going to have, okay, something like CH2OH and then CH3, CH3. Now, this is a primary alcohol, okay? This primary alcohol, there's actually 2O. So that's definitely going to be a carboxylic acid. So primary alcohol, to change into carboxylic acid, it must be oxidized. So I know now I have carboxylic acid, okay? I have carboxylic acid here, and I also have another carboxylic acid over here. Then they actually started to heat with concentrated acidified KMnO4. So this one, when something that is actually heated with concentrated acidified KMnO4, the bond that is broken must be a double bond. So how it's broken, if let's say you have two products, definitely this is going to be not a simple oxidation, it's going to be breaking of double bond. So I end up spending a lot of time figuring out what is this and so on, okay? But the moment I look at the question, okay, the question is much more clearer. I think whatever basic things that I actually work out over here will be enough to actually give the answer over here. Like for example, suggest region and condition for reaction 3. Now, reaction 3 is oxidation, okay? Brilliant, can you help to suggest me the region and condition? Oxidation of alcohol. There are only two types of oxidizing agent that normally we use in lab, which is a strong oxidizing
Potassium dichromate, yes, sir.
Yes. K2, you can actually use potassium dichromate, acidified, okay, and then condition? Heated under reflux, okay, heated under reflux. You cannot just simply heat because this is a primary alcohol. If you just simply heat, it can actually be aldehyde also, because aldehyde will be further oxidized to become carboxylic acid. So you need to actually make sure that in order to get the carboxylic acid, okay, because you are getting the carboxylic acid, you need to actually heat under reflux. So it's very important. Now, since we are learning something over here, so I want to ask also Michelle. Now, let's say if I have a primary alcohol, but I do not want carboxylic acid, I want aldehyde only. Michelle, how do I get aldehyde? Okay, Michelle is not responding. How about Cindy? Cindy, primary alcohol, how do we change into?
In toilet, sir.
Yeah?
Michelle in toilet.
Okay, Michelle in toilet. Okay, Cindy, can you actually help me over here? Primary alcohol, I want to change into aldehyde rather than changing it into carboxylic acid. How do I do that? We'll select another one person, Nicole. How do you change primary alcohol to aldehyde only rather than changing it into carboxylic acid?
Distill immediately.
Okay, that's only one point of it. Okay, there are 3 points over there. Distill immediately, but you need to heat gently.
Oh.
Heat gently. Distill immediately. There's another one more.
K2Cr2O7.
Add oxidizing agent drop by drop. It means once you add one drop, you distill immediately. Once you add another drop, you distill immediately. So that is actually 3 types, 3 ways. How do you get the, it means 3 ways or 3 necessary steps that you need to follow to get aldehyde. If you don't follow this, okay, you are going to get carboxylic acid. Okay, this one additional knowledge. Okay, what type of reaction is reaction 4? Okay, let's actually look at reaction 4. This is going to be KCN. Okay, then the Br is going to be replaced by Cn. So this one, what type of reaction is this? Is this addition or substitution? Halogenoalkane. So what type of mechanism is this? Aditya?
So, which one?
The Br changed into Cn. What type of reaction is this?
Nucleophilic substitution.
Yes, nucleophilic substitution. Now, suggest regions and condition for reaction 5. Okay, let's look at reaction 5. Now, this one is going to be, I told you, okay, this one, nitrile, reactions of nitrile, it's changing into carboxylic acid. Okay, so region, this one definitely not forming amine over there. So it's forming carboxylic acid. So we are looking here. Okay, it means formation from nitrile to become carboxylic acid. So how do you get from nitrile to become carboxylic acid? So there's only one way. Okay, this one is by using, maybe I'll just select one person over here. Michelle, are you here already? Not yet. Okay, maybe Nagin, are you here? Richard? Kathleen?
What?
Yeah, Kathleen. How do you change nitrile to become carboxylic acid? For reaction for nitrile, there are two types of reaction. Okay, one reacting with dilute HCl to give you carboxylic acid. Another one is being reduced using sodium and ethanol. That is going to be to reduce to amine. So basically something to do with HCl. So region is going to be HCl, okay, hydrochloric acid. But what are the conditions?
Is it heat?
Heat, or you can just put heated under reflux is okay. Okay, heated under reflux. And one more. Is it, you can see that they need
PCN.
water. Okay, they need water. So the region must be the HCl. Must it be concentrated or is it going to be diluted? If you need water.
Dilute.
Okay, so this one must be diluted. Okay, diluted HCl or dilute HCl. Okay, heated under reflux. Okay, that will be helpful for this reaction. Now, here, these are the things that we were thinking, you know, I was overthinking about D. But the question is just simple. They say name the functional group in C that has reacted with hot concentrated acidified potassium manganate. So functional group in C. So this is going to be C. So if you have something when you are heated with a concentrated acidified KMnO4, divided into two. Something that is broken into two. So it must be dealing with a double bond. So the double bond, so how do I put the functional group? The functional group is alkene. That's it. Is that okay? Suggest the name of functional group in capsaicin that has reacted in reaction 1. Okay. What is the functional group that has reacted in reaction 1? You can see that this is C18. It means something over here, they are combined. Both of them were combined together. So when you boil with H3O+, it means this is using acid. It means some kind of hydrolysis is happening. It means we are using water to break them. So if you are using water to break them, okay, the answer, okay, can be either, okay, it can be either, this one might be ester. Okay, if you are using acid, ester can be broken also. Or if you are using amide, amide also can be actually broken if you are using acid hydrolysis as well. So if your answer is either ester or amide, it will be accepted. So I'm going to actually put it as, okay, here I think better to put it as, because there's NH2, there's carboxylic acid here. okay, I will rather put it as amide, okay. But do remember, answer can be amide or ester, but I'm putting it as amide. Okay, why I'm putting it as amide? Because easier for me to draw, okay, this structure later. Now, here they ask you, work out the structure C to F, okay, of capsaicin and draw the structural formula in the boxes below. So here we need to actually draw. So if I erase these parts, okay, and I want to draw this structure, so how do I draw? Okay, so here, okay, if you have the KCN, okay, KCN, so what's going to happen is going to be, I'm going to have 4 carbon, okay, and then there is going to be CN, so 1, 2, and then CN, CN. Okay, I'm not going to complete the hydrogen, but you can actually put the hydrogen in. And then after that, okay, you are going to actually react, okay, this reaction 5, I know it's going to change it to carboxylic acid. So I'm going to have 4 carbon, and then I'm going to have a carboxylic acid here and another carbon with carboxylic acid over there. So this is going to be for this. Here, okay, I have a primary alcohol. Okay, primary alcohol is changing into carboxylic acid. So using this, okay, based on that, I'm going to actually write CH3, CH3, C, and this part is going to actually change into carboxylic acid. Why? Primary alcohol, they will change into aldehyde. Then after that, they will change into carboxylic acid. In this case, they are changing to carboxylic acid. Why? Because there's 2 over there. Now, how about C? How do I work out the C part? Now, the C part, okay, I'm going to actually work out because this one, we know that there is a double bond, which is actually broken over here. So what's going to happen is, okay, I'm going to just draw like something like this, okay. This one, probably I'm going to actually keep this as, I'll start from here. C double bond O, OH, okay. And then I'm going to have 1 carbon, 2, 3, 4. And then here there's 5, okay. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, and here what I'm going to have the double bond over there. And then here I'm going to have the H, why H? Because I want to indicate that this is going to be 1R group, CR, and then H double bond, where this one will change into aldehyde, then further change into carboxylic acid to give you this, okay? So I need to actually keep it as H over there. And then here, this part, okay, must follow from here. So this part is going to change into carboxylic acid as well. So I'm going to put C1H also because I want it to change into carboxylic acid. And then with another carbon, this carbon, and then H, CH3, and then CH3. So this is going to be my structure for C. After that, okay, you see this structure, okay, you have NH2, and then you have the carboxylic acid. So what you can actually do, okay, you can either, okay, react this carboxylic acid with this phenol to give you ester, okay, but I will actually, since I'm more, I prefer the formation of, okay, I prefer the formation of amide over here. I'm going to actually react with an amine group and then carboxylic acid group. So I'm going to work out for this. So if I draw, so probably I'll just draw something like this, okay? And then I have OCH3, OH, and then like this, and H2, okay? This, one of the H will stay, and then this OH will be gone, okay? So H will be here, and then you will have C double bond O, and then you have how many C? 1, 2, 3, 4, 5. Okay, so 1, 2, 3, 1, 2, 3, 4, 5. Okay, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then there is a double bond. And then you have C, you have C, CH3, CH3. Okay. So this is the structure, okay, that we are looking for. So this one is done. Okay. I want you to actually have a look, okay, at the whatever things that I actually have done. Anyway, later I'm going to actually upload the answer key. The answer key is given in form of a skeletal formula. Okay, so that is easier. But take note, they do accept something to do with ester. Okay, so you, instead of actually giving the answer in this way, they do give you the answer in ester. But have a look at here, and then just have a OCH3. So basically, it's the same here. Okay, it's the same here. So basically, you can either choose, okay, to give you this one, no issue. So this one, if you are selecting ester, if this one, if you're selecting as amide. Okay, so I'm selecting it as amide. Okay, but if your answer is ester, then your answer should be this one. Is there any question? It's already 9.
No.